Hi everyone, in this video we're going to talk about factoring and review it. So we have some steps to help us through this. So step 1 is to always look for a GCF, that's a greatest common factor. Anything other than 1 that goes into all of the terms. Step 2, then you ask yourself if we have a binomial. If we have a binomial, then we need to check to see if it is a difference of squares or a sum or difference of cubes. We're not able to factor a sum of squares, but we do have the formulas down below. Step 3 is to see if it's a trinomial in the form of ax squared plus bx plus c. And we're going to use the AC method that looks like the x, where we organize our thinking. We take the first term, which is a, multiply it by the last term, which is c, put it on top. Then we see the middle number on bottom. We figure out what we can multiply to get the top, add to get the bottom. Then if we have any other polynomials that have multiple terms, then we go to factor by grouping. In step 5, we just make sure that we have factored everything out first before we say it is our final answer. We want to make sure that it's completely factored. So here we have some formulas. Difference of squares is one of the most common ones. Sum of two squares, again, cannot be factorable. So that's what this is saying right here. It can be, but it's not with real numbers. Perfect squares, we don't see too often. I mean, we see them, but they're harder to recognize. So if you don't recognize them, that's fine. You can still factor it like normal. And then here is our formula for a sum and difference of cubes. I did have a mistake in the notes page, so make sure we fix that and change that to a cubed instead of a squared for the difference of cubes. So looking at our first example, we want to make sure that we factor completely. So when we factor completely, we want to make sure that we can't take anything else out or break it up in any other way, shape, or form. So looking here, it looks like it's a GCF problem. Or at least it's going to start off that way. So I see that both 2 and 8 are divisible by 2. And I see that both terms have at least an x cubed. So that's what we're going to factor out for the greatest common factor. So when we do that, we're going to divide each term by a 2x cubed. So 2x to the 5th divided by 2x cubed is just an x to the 2nd power. The 8x cubed divided by 2x cubed is going to be 4. Then when we're here, most of us would like to stop here, but we see that this right here is a difference of squares. So I'm going to make that note. I'm going to abbreviate. So we need to keep factoring. So our greatest common factor is going to keep staying there, and we're going to break this up. Some of us like to identify the A and the B, so we can plug it into the formula that's right here up above. So once we know A and B, we can plug it into A plus B and then A minus B. To get A, we're going to take the square root of x squared. So what can we multiply by itself to get x squared? That would be x and x. The square root of 4, what can we multiply to get 4? That would be 2 times 2. There's my A, there's my B. Now we plug it into the formula. So we get x plus 2 times x minus 2. And now we have it completely factored, and this would be our final answer. Going ahead and looking at number 2, notice that we have 3 terms this time. We still check for the greatest common factor first. So it looks like everything is divisible by 3. And everything has at least an x squared. So we're going to start by factoring that out. Then we're going to see what we have left. So when I divide out an x squared, it leaves me with, 3x squared, it leaves me with an x squared minus 6x plus 9. Now I see that I have 3 terms, so this would be a trinomial. When we have a trinomial, that's where we use the x to help us. So to get that, we're going to take this first number, which is just 1, multiplied by the last number, which is 9. When it is just a 1 in front, it makes it easier for us. We don't have to do the extra work with the factor by grouping unless that's just what you want to do. Then we're going to take this number right here, and we're going to write it on the bottom, which is a -6. So we think to ourselves, what can we multiply to get a +9, add to get a -6? That'd be a -3 and a -3. So when we factor this, we get 3x squared, and then it's going to factor into two factors because it just has a 1x squared, and it's going to be x minus 3 and x minus 3. Since these are the same terms, what we can do is we can combine them and show it as x minus 3 to the second power. And that would be our final answer. Looking at the next one, we see that we have 3 terms. We notice now that there is not a greatest common factor, so we can go straight into factoring with the x. So this time there's a number in front of our variable being squared. Again, we make sure that we multiply it by that. So let me be consistent with my colors. So we're going to take that times that. 6 times 4 is 24. Then we take this middle number and we write it on the bottom. So we have to think to ourselves, what can we multiply to get 24? Add to get -8. Multiply to get 24. Add, oh, not -8, -11, my bad. So that would be -8 and -3. So now with this, what we do is we take everything except that middle term, and that middle term we're going to split into a -8a and a -3a. So it gets split into two different terms. That still adds to give us that -11, and then we have the +4 at the end. From here, we're going to group the first two terms together. We're going to group the second two terms together. If you want to flip-flop the -8 and the -3, that's perfectly fine. You'll get the same answer. So here, when we do this, we see that this has a greatest common factor of a 2a. When we factor that out, that leaves me with 3a minus 4. Then I look at that second group. It has a greatest common factor of a -1. That leaves me with a 3a minus 4. So what we want is for this to be the same as this, which is what we have. So we can factor that out as 3a minus 4, and then it leaves me with a 2a minus 1. And that would be the factored form for this. Going ahead and moving on to the next one, if you want to pause the video and give it a try, you can do so. So this one, we notice that it is just a 1 in front of the x squared, but we can still take it and multiply it by that last number to be consistent. So when we do that, we get 6. On bottom, we get 5. And because it's just a 1, we can go straight into the factoring. So what can we multiply to get 6? Add to get 5. That would be 2 and 3. So when we factor this, it would be x plus 2 and x plus 3. If you wanted to break it up like we did the last one, where you split up this term right here into two terms, you could do so, and you would get the same results. Looking at this next one, we see that now we have 4 terms. So when we have 4 terms, the only thing we know how to do is to factor by grouping. So that's what we're going to do. We group the first two together, we group the last two together, and we see what they have in common. So my first group, it looks like it just has an x in common. So that leaves me with a y plus 8. My second group looks like it has a 3 in common, and that leaves me with a y plus 8. We know we're doing this correctly when what's inside the parentheses is the same thing. So I can write that as one factor. I can factor it out, and then it leaves me with an x plus 3, and that would be it for factoring number 5. Okay, looking at number 6, we see that we have a binomial. That means we have two terms. First thing we do is check for a greatest common factor. So we do have a greatest common factor of 3. So I'm going to factor out a 3 first. When I do that, it leaves me with a 4x squared minus 1. Then I see here that I have a difference of squares. We need to make note. So we can keep factoring. So we need to know what A is, we need to know what B is. Well, the square root of 4x squared is 2x. The square root of 1 is 1. So when I factor this, I get 3 times 2x plus 1 and 2x minus 1. And that would be it for this one. So again, we're just getting some practice with the factoring here. I'm going to do a couple more with you and then leave some for you to try on your own, and you can check your answers on your own time. So looking at this next one, I did want to change this to a plus sign. So go ahead and change that. So I see that I have an x cubed and an 8. We need to know, that this is a sum of cubes. So this is a sum of cubes. It was a difference of cubes first, but I changed it to a sum. So we need to know what A is, we need to know what B is, and then we have its own formula that's on the front page that goes with it. So what times itself 3 times gives me x to the 3rd power? That would be x. What times itself 3 times gives me 8? That would be 2. 2 times 2 times 2 is 8. So the formula tells me this, that we're going to take it as A plus B times A squared minus A times B plus B squared. So we're going to plug in our A and our B into that formula, and that's how this gets factored. So it is going to be x plus 2 times x squared minus 2x plus 4, because 4 is 2 squared, and that is how that gets factored. Okay, looking at our next one, very similar, but this time it is a difference of squares, or not squares, of cubes. So a difference of cubes has the formula A plus B times A squared minus AB plus B squared. Actually, nope, I messed up the signs. This sign right here should be a minus, and this side right here should be a plus sign. So all we need to do is identify our A, identify our B. So what times itself 3 times would give me 27x to the 3rd power? That would be 3x. And what times itself would give me 1, which would be 1. So when we plug it in, we get 3x minus 1. Then we need to square 3x, and that becomes 9x to the 2nd power. We multiply 3x times 1, that is a 3x. And then we square 1, which is just 1. And that would be that difference of cubes factored. Looking at the next one, we have x squared minus 16y squared. So I have two terms. It looks like a difference of squares. So let's write that out. Running out of space. So we do need to identify our A and our B. This time, what times itself will give us an x squared, which would be x. What times itself would give us a 16y squared? That would be a 4y. So from here, we go straight into our formula. We have a plus b, which is x plus 4y, times a minus b, which would be x minus 4y. And that would be fully factored here. Okay, So what I would like you to do is pause the video and try the last 9 just to see how you do. And I'll have the answers in just a second to make sure you did them correctly. So hopefully you gave them a try. I'm going to write in the answers for 10, 11, and 12. And then I have the answers already for the other ones. Again, if you have any questions on how we got these answers, please make sure you ask. That way you can get some help. So there is 10, 11, and 12. And then I have 13, 14, and 15, and 16, 17, and 18. So again, double check, make sure you're good with these. If you have any questions, write them down and make sure you ask in class.